So now we made it work for a small image. Great. We have a very small image and it works. Well, that's kind of our first step, right? We've got it working on a small image. What about a larger image? Let's actually 400 by 400 and 100 by 100. And by the way, now this image is so big that we're not going to see the whole thing in the file anyway, because I don't want to look at like 1600 numbers. So I'm going to get rid of this line here for now. We don't need it because this image is really big and it really wouldn't show up anyway. And now, oops, that's a tiny white. Let me go back and look. Oh, I forgot to increase my length. I only did my length of 2 pixels. That should have been 200. So 100, 100, 200. Now we're getting a sizable image with a very big piece in there that's been turned to white. All right, so now we have it working on a large image. And again, there's no point to the text file, so I'm actually going to delete that code in a second, but you can see it worked. So great. We have something that at least colors the insides, makes an image and colors a section that we decided to change, and it created it. So that's going to be our first version. And we're going to call that first version done. And we'll call that version 1. Right, version 1 is done. We're going to do updates to it and make version 2. But we have something working. And that's the whole part of incremental development, is just get something working in steps. And now we can write a box somewhere on an image. And let's start here. I don't want to create an image anymore. Remember, our goal is to make a cat turn into these colors. So let's actually grab the cat. So instead of creating an image, I'm going to use the load image function from the library, which we used before. And I'm going to load the cat. And remember, I'm in the same folder as the cat JPEG. And by the way, you can use, remember, JPEGs or PNGs. My output could be a JPEG or a PNG. So cat JPEG. So now we're going to load the cat. And we're going to write a white box directly on the cat. And again, this is a pretty big image, so I'm not going to print any of the text out. But let's actually see if this worked. Let's see if we get something on top of our cat. And so here's our output. We now have a cat, and we have a whole bunch of white text in that region on the cat. And we're going to add some more features to this, but let's actually stop for a minute and think about what we have here. What did we do? So far, we took an image. Could be the cat, could be the other image. Inside of this image, we took some region. And the region was 100 by 100. And if this was the cat, by the way, it would be 800 by 600. Obviously, this is not the cat image or the cat box, because this box is the wrong shape. But if let's just say that's the cat. This pixel over here is 100. Remember, length is 200. So that corner is 100, 300. That corner is 1, and this corner is 100. Actually, this corner is 100. Oops, sorry, 300. Putting the row first, 100. And then this corner over here is 300, 300. Okay, and that's because we're going 200 in both directions. So this is what we've done so far. But that's not what our goal is. And if this was the cat, right? If this really was the cat's actually bigger than that, right? But our goal is not to have a bunch of white pixels on a cat. That's not our goal. Our goal is to have the red and green alternating colors. And so our goal is to create 4 quadrants and to create this checker pattern. And in the top checker pattern, we only want the red. And then same with the bottom right. And then in this quadrant over here, top right, we want green, and the same with the bottom left. And so this should be red, red, green, green. This is the pattern that we want to do. And so now we have to figure out what we need to do this. So how do we split a box in 2? In order to split a box in 2, we have to figure out the center point. We have to know what that point is right in the center there. Let's call that the midpoint. So I need to know that midpoint. Giving that midpoint, I can do a lot of calculations after that. So currently, start row equals 100. End row equals 300. And I need to know at what the midpoint of the row is. And so I have to run a calculation. And when we have that midpoint, we can do if statements to say, okay, you're in quadrant top left, or you're in quadrant bottom right, or you're in quadrant bottom left, or top right. And so we can figure out what quadrant a pixel falls in and modify its color. The calculation for this, and there's a couple of ways we can do this, but if you think about it, we need to go to the start, and then we have to add to it. And there's a couple of ways you can do it. One way is to take end row minus start row and divide that by 2. And mathematically, let's see what that looks like. 100 plus 300 minus 100 over 2, which is going to equal 100 plus 100, which is going to equal 200, which makes sense, right? I have length of 200, the midpoint should fall 100 pixels away from the start. Again, this is just one way of doing it. There's actually a reason we like to do midpoint calculations like this. Let me show you another calculation, and it won't be a problem in Python. Some of you may have thought of this as well. What if you just took start and end and divide it by 2? That would work too. 300 plus 100, 400, or actually 100 plus 400 divided by 2 would still give me 200. The reason that we don't like doing this is not because of Python. Python can handle it fine for any number. But in other languages, when you're doing midpoints on large numbers, can lead you to a problem called overflow. So if you add 2 large numbers together and it goes over the size of the number, it'll actually truncate the number in a weird way. Not a problem in Python. Python handles very large numbers. But Java, C++, C, if you try to add 2 large numbers together, and then these aren't large, but you could have huge images that you could do this to, and it could cause problems. So it's not the preferred way because it has this potential for overflow. This is the preferred way for doing midpoint calculations. And so that's the one we're going to use just because it's a better version that works on all computers, all compilers. So now let's go and implement this. Which means we need a couple of extra variables. Mid row equals start row plus the end row minus the start row divided by 2. Remember, it's going to do the division first. But it's actually going to do the parentheses first, then it's going to do the division. And the column is literally the same calculation because we're going to start the same, but it's going to be use the column variables instead of the rows. Now, we have that calculation. We have to figure out, how do I do this to make those other colors? I don't want the pixels to be white. I don't want those to be white. I want them to do checker pattern. So for now, I'm just going to move that out of the way and think about my goal. What's my goal? Color the top left and bottom right quadrants as red, right? Bottom left, top right need to be red. Well, that should be easy enough for us to figure out. We know how to check for those kinds of things. We're already inside a start row and end row, so we don't have to worry about numbers outside of that. But now we just check against the midpoint. If the row is less than the mid row, remember, where's mid row? Oops, like too many tabs here. So if R is less than the mid row, so here's the row. If R is on the left side of it, it's going to be red. But that's not all of it, right? That's half of it. What else is going to make it red? Oops. It also has to be, C has to be less than mid column. In order for that top left quadrant to turn red, both of those columns have to be true. We have to be less than the mid row and we have to be less than the mid column. That's only going to give us the top left. So we need to extend this for the bottom right. Sorry, that's again the wrong thing. So we need to OR this because it can be either in the top left or it could be in the top right. And then we look for the other side. And by the way, what happens if I don't do mid row or if I don't do equals to mid row or mid column? What happens if I do that? What happens if a pixel lands on, and it's going to, right? Because it's going to cover every pixel from start column to end column. What if the pixel lands on one of the lines? Because here, we're looking for this quadrant here. But if it lands on one of the lines and we have this statement here, it's not going to see it, is it? One of these needs to cover, one side of these needs to cover the axes, the lines of the midpoints. Otherwise, we don't get it. And we'll have this weird color right in the center of our image instead of our quadrants. So if the pixel is both less than the mid row and the mid column, then we're going to turn to some other color. Or if the pixel is greater than equal to mid row and greater than equal to mid column, remember it's already going to be within the same, within our square because we're only looking at pixels inside the square, so we don't have to worry about things outside of the square. And if it is, we just grab the pixel, just like we've done plenty of times. And we're only going to keep the red component of the image. We're going to zero out everything else. So this is literally the same thing that we just did in our review, except now I'm only keeping the red and I'm getting rid of the blue and the green. I only want to see the red. We're not done yet, but this is a good place to check to see if it works before I add the other part. Just to see if we're in the right place, if I have any errors. Make sure I close that. Oops, actually that reloaded the image. Notice the image now has red now instead of white. The other part's empty because we didn't do anything to it this time. But the top left and the bottom right both turned red. It kept the red component and dropped the blue and the green component. So just to give us variations of red.